Georgia Department of Education Math Professional Learning videos. This video is specifically designed for 4th grade educators. This segment focuses on Standard 4 MD2. Standard 4 MD2 states that students will use the 4 operations to solve word problems involving distances, intervals of time, liquid volumes, masses of objects, and money. The problems also will include simple fractions or decimals and will require expressing large units in terms of a smaller unit. Students will need to represent measurement quantities using diagrams such as a number line that feature the given measurement scale. One common student misconception is that students believe that larger units will give way to larger measures. To overcome this misconception, students should be given multiple opportunities to measure the same object but with different measuring units. For example, have students measure the length of a room with 1-inch tiles, 1-foot rulers, and with yardsticks. Students should notice that it takes fewer yardsticks to measure the room than the number of rulers or tiles that are needed. So how does 4MD2 work? Students are being asked to combine their understanding from different domains as they are solving these measurement problems that utilize the 4 operations. As you can see, the knowledge that students have received during this academic year and the previous ones are very vital at this point, and it's all beginning to come together. A question most educators have when it comes to any word problem standard is, what does an appropriate word problem look like for my grade level? Well, to look at this for 4th grade, let's go back and look at some of the key standards that shape a 4th grade version of a word problem. Standard 408.3 gives us the multi-step part of our word problem. MBT4 is our adding and subtracting multi-digit numbers. MBT5 gives us multiplying 4 by 1 digit or 2 by 2 digit. MBT6 is dividing 4 by 1 digit numbers. Please remember, if there is a remainder, it needs to be a whole number, and then also embrace that opportunity to allow the students to interpret that remainder and what it truly means in the context of the problem. NF3 gives us our fractions and mixed numbers domain. That's where we're adding and subtracting fractions or mixed numbers, but with like denominators. And then we have this simple decimal statement. In 4th grade, our work with decimals is very limited. And in 5th grade is when our students actually begin working with decimals to the hundredths in all 4 operations. So as you can see, we need to kind of stay in the lane of tenths place when it comes to this. Also, 4MD2 deals with money. And in essence, we are laying the groundwork for that 5MBT7 standard that students will see the next year, because we're hoping that by dealing with money now, they will make that transition to hundredths place in the decimals a lot easier. So as you can see, a lot is going to go into an appropriate 4th grade word problem. Now we're going to join a class that is in the middle of a 3-act task by Robert Kaplinsky entitled How Many Movies in One Day? Notice how the 2 students are sharing different strategies for calculating elapsed time, and how student 1's strategy is based off of a misconception.
We're going to watch it, and then we're going to watch Sing. Okay, we got at 1 hour.
Sing. All right, sing.
1 hour and 15 minutes. That would be
5 hours. No.
wait,
6 hours.
Yeah,
6
it's
hours.
gonna be 6. So it's gonna start at another movie's gonna start at 6.
Yeah, 6.
Yeah. Wait, is 6 exactly 6?
Yeah, look. 5 plus 1. Then put
It's gonna
4 plus 1 equals 5. And then put the 1 equals 6. Then you're gonna have 0. So 6 o'clock.
But it's by 60 minutes. It'll be 6:20.
No.
It'll be 6:20.
No, because look. Hear me first. Look, hear me first.
It'll be 6:20. Cause look, 1, 2,
That's what's
3,
okay.
4, 5, 6:40. It will be 6:40. Cause it's
No, because
60
look.
minutes.
The movie?
Yeah, cause
No, because
an hour equals 60 minutes.
Yes.
Using student 1's initial strategy and an elapsed time number line, listen to how the teacher's questioning helps the student discover why this strategy does not result in a correct answer.
So if we know that 1 hour is 60 minutes, so we do a hoop, and right there is gonna be 60. It's gonna be it's gonna be 1 hour.
Okay.
So then from right there will be 5:50. And then since we have 50 minutes left, we add 10 from 50. We take away 10 from the 50 that we have, and we're gonna have 40 left. So then from there we have 10 minutes.
Why did you take 10 away from the remaining 50 minutes?
Because 60 minutes is equal to 1 hour.
Okay.
So since we had 50 and we add 10, it's gonna be 60. So right there it's gonna be 6 o'clock.
Okay. So that's very different from the end time that we got here. Can you tell me how you got this answer?
Notice, the teacher intentionally has the student compare the two strategies side by side as a critical sense-making strategy. The teacher's goal is to see if the student can discover and explain the procedural error on his own.
Well, I got the answer because you have 50, but if you add those, it's gonna be 10. So you have to take 60 away. So then you have 4 left. So then you add 1 right there. So then it's gonna be 4 plus 1. Then add the 2, which is gonna be 6.
The student struggled to clearly articulate his reasoning in response to the general question, how did you get 6 o'clock? So now the teacher will ask, why didn't these two strategies give the same answer?
Why didn't it work out to be the same?
Because when you add like that, you have to add the ones first, then you add the 10, then the hundreds. But then on the number line, you don't have to add by the ones, the tens, or 100. You could add them however you want.
Okay.
The student struggled to clearly articulate his reasoning in response to the general question, why didn't these two strategies give the same answer? And it's very likely that he has a misconception about the quantitative relationship between minutes and hours when using the stacking procedure. Therefore, watch as the teacher will rephrase the question along these lines to attempt to uncover the misconception.
And also, when we're adding here, we're adding minutes with minutes.
Yes.
50 minutes plus 50 minutes is how many minutes?
100 minutes.
Is 100 minutes the same as 1 hour?
No. So then you have to take away 40 from the 100 minutes, and then you have 60 minutes, which that equals to an hour.
Okay.
So this student does, in fact, understand that 100 minutes should be decomposed into 60 minutes and 40 minutes for regrouping, but he does not apply this understanding when using the stacking algorithm. This is the reason why number lines are much more appropriate for elapsed time problems, because they better allow students to make sense of the numbers and operations as well as the context of the problem.